Hello, everyone, and welcome back to the Karajan Music Tech Conference. I'm now in a room together with Sam Aaron, who is our performer tonight. Hi, Sam. How are you doing? I can't hear you.
Is it working now? Sorry.
Yes.
Too many buttons. It's absolutely splendid to be here. I said some very important things just now, but let's forget about those now.
Sam, it's great to have you. You are the creator of Sonic Pi, which is a live coding environment for making music, and it is an absolutely phenomenal experience to see and hear how music gets created with code, with computer code on the fly. So we're so excited to having you. And I can't wait for the performance, so I want you to go straight at it, really, and then we'll talk afterwards a little bit about what everyone can experience.
Of course. I mean, and it's important to say that everything I'm going to do, and we'll talk about this more later, I'm sure, I can teach to a 10-year-old child. The only difference is practice. So just like a guitar or a piano, everything I'm doing is just built on top of practice and virtuosity through practice, basically. So nothing I'm going to show you is rocket science. It's just, if you can read notation, like crazy dots and lines and scores, then you can read code, because notation is code. We'll talk about that later as well, I'm sure.
And all you need is a computer and the code that you developed.
Well, so if you want to compose music, all you need is a piece of paper and a pen. And code is nothing more than a different form of music notation. And it's really important to get that into your head. It's not anything different than just a score that happens to use words instead of dots and lines. Yeah.
Fantastic.
And all the score I'm going to show and work I'm going to do, I'm going to be projecting the code in various forms, is all simple enough to teach a 10-year-old child. And we do use Sonic Pi to teach introductory music and computer science in schools. So it's not just a new kind of musical instrument. It's a tool for education as well. Okay, right. Shall I start? So,
great. I'll talk to you later.
I'll go into like performance mode, so I'll see you later.
create precisely the same programs we're creating right now with these tools of complexity with drastically simpler tools, right? I did C++ for a long time. I did Java. I did C#. I know how to make big systems in those languages, and I completely believe you do not need all that complexity.
Hello.
Oh my God, that was so cool, Sam. Thank you so much.
Thank you very much.
You still have the code all over you. It was such an amazing experience. All of this comes from the code that you write, and then you use the instruments to change the sound on the fly.
Yeah, so code is nothing more than notation. And I think that when we look at the musical innovations of the last 1,000 years, we might talk about the computer as being a really exciting technology to really focus on in terms of innovation. But actually, I think really the innovation, which was the creation of musical notation, was really key. And combined with the innovations at the time, the technology of the time, which was the printing press, allowed for the dissemination of music in ways that are just so profound, that allowed people to share their musical ideas all over the world and also through time. In fact, now we can study and reproduce the works of composers that are long since deceased. And I'm just doing the same, but with code. And instead of the printing press, I'm using the computer. And I'm using code to combine and join up all the things in my studio. And so the code is generating the timing signals, it's generating MIDI events, it's generating open sound control events, controlling the visuals, controlling the music. Of course, I'm also able to physically interact with it by pressing the MIDI keyboard, but this Moog synthesizer here is actually connected to the Raspberry Pi, which then takes the MIDI signals and sends it back and then can modify it, and you can also trigger the other synthesizers on the fly. And I think you can see here, it's actually modifying this grid device. You can see the control values. I don't know if you can actually see that. The lights are flashing as I'm manipulating it. So really, I'm just using code as a tool, a technology, to combine all these different musical ideas and musical creations in a way that allows, because it's text, allows me to share that work, share those compositions, allow other people to learn how I've done it. If I can see other people's performances, I can read their code, understand how they've made it. There's no having to reverse engineer. Like, if you think about the last sort of 100 years, how many pieces of work, musical pieces of work, do we not have access to the raw materials, their source code? We have the source code of Beethoven.
Yeah, in the
but we don't have the
sketchbook,
source
right?
code of Aphex Twin.
We have the sketchbooks of Beethoven, but they are really, really hard to read. And I think that is the big difference. Your source code adheres to, the principles of writing a software, and so it is understandable by a large proportion of the world. versus the sketchbooks of Beethoven, which are really hard to read and no one really can agree on what is actually written in there.
Yeah, well, that's the other thing, is once you have code, you have all the tools that programming languages have had for decades now, which is mostly about powers of abstraction. So you're allowed to manipulate the level of your composition to match the level that you wish to communicate. So rather than having to convert your musical ideas into a form that is really amenable for musicians to sight read, so if I want to scale E minor pentatonic, I'll write those dots out on the lines. In my code, I can actually work at the level of abstraction I'm thinking of as a composer. I can write the phrase E minor pentatonic.
Yeah.
If I want to choose some random notes in that, I can talk about choosing random notes. I don't have to sort of turn them into these dots, which then you have to, if you want to try and interpret what the composer was thinking, you have to try and reverse engineer their thoughts.
Right.
When you're using code, you have the opportunity, you don't have to do this, but you have the opportunity to change the level of abstraction to match what you'd like to communicate as a composer. And I think a real sort of pitfall that people fall down to when they talk about codes, they think it's all precise and you can't change it, there's no interpretation. With a violin, I can put feet. Of course, like, code isn't going to replace any of these things, but you do not have to interpret the code precisely. I mean, it is just a language. The computer can precisely interpret it, but you can also add in randomization, you can also add in bad timing, you can also add in swing, you can also add on all these things.
Yeah, or you could use one of these instruments that you have there.
Reproducible, that's deterministic.
Yeah.
So one of the core concepts of Sonic Pi is, even though you've got a lot of randomization functionality in there, to choose random notes from scales, to choose random timings, it is all reproducible and deterministic. So that if I use randomization in my composition and send you the code, your computer will make the same choices. And so you'll hear what I intended you to hear. And so that's really, I think, an exciting thing. That we've spent hundreds of years recently trying to figure out how to actually break out of Western notation, and we try and figure out different ways we can actually score these kind of ideas, especially to do with like Steve Reich phasing and weird timings and different kinds of representations of timbre and I think studio kinds of things. Code really can do all those things beautifully. We should be embracing it.
I think what you say is very interesting from a sort of musicological standpoint also. And I don't want to dive too deep into the abysses of musicology and theory, but Herbert von Karajan, the conductor, he used to say, well, actually, the music notation in the way that we have it is completely insufficient because it cannot capture all of the ideas and the meanings that a composer has. So in his words, there has to be a new kind of language for writing down music. And I think what you are demonstrating is leading the way in that direction. And that's why I think it is such a beautiful fit to have you on a conference that comes from the actually classical music world. And I'm just so excited about this. I want to ask you one question about the future, and that is, you have a language in which you write down your sort of musical ideas, and then it gets executed by the computer. Is it possible to think of a future in which I, with my natural language, talk to your system and say things like, give me a bell with a reverb at 120 bits per minute? Now,
yeah, I mean, that's 3 lines of code.
And it's possible already?
Yeah. And I think that the interesting thing is, it's not about one language, right?
Yeah.
I think that the Western notation is beautiful for orchestras to be able to sight read their score very quickly. And it's really designed for that, isn't it? That's the main sweet spot. And as you're right, it doesn't really capture a lot of the composer's thoughts or ideas or concepts particularly well, and certainly doesn't capture things like timbre other than with violin or with piano. But I think that code actually isn't a language, it's languages. Yeah. And I think that the key thing is that Sonic Pi is one of many live coding languages, and even in Sonic Pi itself, you can start to create your own mini language which represents maybe just a piece of music you're working on. You might have a mini notation which is just perfect for representing those thoughts. And I think that's critical. It's not just about language, it's about languages, and ideally they're interoperable, they can be executed by a machine, but also they don't have to be. Like a core thing about Sonic Pi is that when you're learning Sonic Pi, you need to be able to get to a phase where you can read the code and hear the music in your head.
Right.
And so that's critical, because that's really important in terms of education and sharing and learning. But also, once you get to that phase, you can reverse that, because you can then hear sounds in your head and know what codes you need to write to create them. And
Right.
that's when you can start to really express yourself in new ways.
Yeah. So a part of Sonic Pi is a huge community of people who use the system, who are in creative exchange with one another. And I know what's very important to you is the outreach to the young generation. You mentioned to me that, you know, any 10-year-old, or maybe you said even 8-year-old can work with the system. What are some of the reactions you get when you go into schools from both the students but also the teachers?
I could spend hours talking about this, so I'll be trying to be as quick as possible. And it depends on where I'm going and what I'm talking to. So it was originally created for teaching computer science.
Yeah.
And so at the time, and still is the case actually, a lot of computer science is taught with, I argue, very boring, really boring approaches like sorting algorithms. And so if you go into a computer science class and say, here, you can lay down a bass track, you know, you can do some drum and bass, you can take the Amen break and you can slice it around and make drum and bass really easily, that gets the kids super excited. So music, just as a vehicle for teaching computer science, is a fabulous thing. So computer science teachers, computer science students, super excited. Music is a whole different world, and that's why I'm really excited to talk here, because when I talk to music teachers, there's so many gatekeepers telling me that this is not real music, it's not a real instrument, and it really surprised me, because I honestly thought the musicians would be the people that would start to understand the value of code as a composition notation, and I run across so many people who just tell me no, it's not. And I mean, it's really difficult, because like in Sonic Pi you can represent a Steve Reich phase pattern with 4 lines of code, 5 lines of code, I think it is. And that's something you can't easily notate with Western notation. So you have so much opportunity to start to write down in a way that can be preserved into thousands of years musical ideas using code. That I would have thought that music teachers and musicologists and musicians would be like all over it with excitement, but it's not yet. It doesn't. I think that the problem is, I think the word code scares people off too quickly.
Yeah, that might be it. Another thing is that there is a tendency in the academic world to build these walls, to build these gatekeepers, and to build these systems that you have to go through. Like, you have to get a PhD to become a professor, and then you have to send your papers, and it has to be accepted by a board of peer reviewers and so on. I have
a PhD in computer science.
I know you have a PhD. I have a PhD. We know what we're talking about, but remember the pain it was to get it. And I think these systems are self-perpetuating, and I love a creative approach that says, like, no, we don't need this. We can empower people to be creative. We can empower people to do a wonderful thing and then share that. And I think this is what music is about. And for me, there is no difference in the type of music that you're doing. I was so excited when Bas Grasmeier suggested you as a performer, and when you agreed to do this, because I wanted our community to also see what amazing things can be done with computers in music.
It's important to state that this is the music that I like making. And with Sonic Pi, people have been reproducing classical music. Someone has written an opera in it. Someone's made really heavy metal Finnish music. So you can write. I mean, you're not just limited to the style of music you just heard. That's just my expression with it.
Exactly.
My challenge to you is to start to use it to express your thoughts and your ideas musically.
Yeah, that's a wonderful closing sentence. Sam, thank you so much, and I'm sure we will be in touch in the future as well. I love that image.
Thank you.
Thank you. Bye-bye.
Bye.
Friends, this is the end of the live show, but it is not the end of the conference. We'll have more programs tomorrow and on Friday for you. So tune in tomorrow as well. Go to our website, www.KarajanMusicTech.com, and make sure to check out what's coming up tomorrow. For those of you who are part of the Karajan Music Tech Brain Trust, we have something very special for you. It is a wine listening session where we pair wines with music, and we get to interact socially a little bit. So take care, everyone, and I'll see you tomorrow. Thanks for everyone who made this day really great. Bye-bye.